All right, welcome to part 2, 7 through some number of problems. Here we go. So we see a right triangle. The most powerful, best thing we can do is right triangle trig. So we're given an angle of 44. We need to go figure out what x is. We need to go figure out what y is. Steve, from the perspective of 44, x is the opposite, adjacent, or hypotenuse.
Opposite.
It's the opposite. And the y?
The hypotenuse.
And the 5 then has to be the adjacent. Okay? So to figure out x, we want to use the 5, but we've got to figure out what the o is. The trig function lets us do that. That has o and a. Matt?
Tangent.
Tangent. So the tangent of 44 equals x over 5. That means we'll go with no switcheroo here. We'll just multiply by 5. We'll get 5 tangent 44 equals x. Do you have that answer for me, Matt or Steve? It says to the nearest hundredth. That's 2 decimal places.
4.83.
4.83. All right, first answer of the day. Here we go with y. Now we don't want to use, even though we now know that the opposite side, the x, is 4.83, we don't want to use that number. We want to use the 5. So the trig function that involves a and h would be, together?
Cosine.
Very good. Cosine of 44 equals 5 over y. Now notice how this one's different. It's got the variable on the bottom. We're going to use our property of proportions, the switcheroo, to make this say that y equals 5 over cosine 44. You want to be just a little bit careful with your parentheses. Matt or Steve, 5 divided by cosine 44.
7.
7.
Wait, I got 6.95.
6.95.
6.95 is right. Okay. On to the next. So these are going to be just exactly 3 examples of what you need to do with right triangle trig. We've got sometimes the variable's on top, we have to multiply by 5. Sometimes the variable's on bottom, and we have to do the switcheroo. And this time the variable's on our angle. So the variable's on our angle. This is the opposite and the hypotenuse. Which trig function uses the opposite and hypotenuse?
Sine.
Sine. So we're going to say the sine of our angle, and in this case it's x, equals 17 over 20. That means that x equals the sine inverse of 17 over 20. Remember, we want this with 2 decimal places. Steve?
70.81.
70.81. Okay. There's some more practice on 9 and 10, but there's nothing new there, so I'm going to leave you guys with just 7 and 8 done. Okay, let's go on to the next section. Number 11.
8's 58.2.
Oh,
I don't know if I got that.
8 is what?
X equals 58.2. 1. 58.2.
All right. Thanks for the correction, Matt. Make sure your calculator's in degrees. And get right answers. All right, number 11 is different from number 7 and 8, as is number 12, because neither of them are right triangles. When we don't have a right triangle, we're probably going to need to use either law of sines or law of cosines, depending on what we have. In this scenario, we have a side angle side as our given. That means we want to use the law of cosines. If you're ready, feel free to tell me the setup for the law of cosines.
X squared equals 23 squared plus 17 squared minus 2 times 23 times 17 times the cosine of 8.
The beautiful thing is you can punch this all into your calculator and then push the square root button afterwards. So we'll have 23 squared plus 17 squared minus 2 times 23 times 17 times the cosine of 81. I'm getting a number 695. Is that consistent with what you're getting?
Yeah.
So x squared is 695 36.6682, and it keeps going. And so we're going to take the square root of both sides with our calculator, second square root, second answer, and I'm getting 26.38. We're rounding that up. It was 3755, and we're rounding that up to 38. Now, sometimes when given this problem, it'll say solve the triangle. That means you have to go get everything. Sometimes it just says solve for x, and we have done so. Let's consider what our givens are in this scenario. Our givens are angle, side, and a side without the angle included. So we have the SSA scenario. More importantly, we have a pair of sides and angles that we know. When we have this relationship, that unlocks the possibility of law of sines, which is a little bit easier than law of cosines. I'm going to choose to go with the sine of x over 19 equals the sine of 82 over 23. Get rid of this 19, and we'll have that the sine of x equals 19 times the sine of 82 over 23. To isolate x, we're going to need to take the sine inverse of both sides. So x is going to be the sine inverse of this number that we have here. So I would suggest in your calculator, you finish all of this work before you grab your calculator, and then you type in 19 sine 82, enter, divide by 23, enter, second sine inverse, second answer, enter. I'm getting 5480. Excellent. So far we've done 4 problems. We did a problem which was right triangle trig with a variable on top, right triangle trig with a variable on bottom, right triangle trig with a variable in the angle. We also were able to do a law of cosines problem, the easier calculator version, and then the law of sines. Next, we'll pick up with some non-calculator problems.